Hello again. This is Foghorn with another installment of Flight School Academics. Today we're going to be doing Basic Aviation Concepts. For this, the 12th of May 2018. For the presentation, or this presentation is part of an ongoing series of academics for the members of Aurora Republic, a premier role-playing organization in Star Citizen. If you are new to the Aurora Republic or visiting for the first time, first let me start by saying welcome. We are glad to have you with us and would love to hear from you if you are interested in hearing more. We are a lawful good organization focused on roleplay, exploration, and social interaction, and are currently active in recruiting on Spectrum and Discord. Tonight, we are going to be talking about some basic aviation concepts, as one might see here. First, some rules of engagement. We are streaming this on Twitch. Anybody in the Discord academics chat with us, be aware anything you say over the mic will be transmitted out over the internet, so you may want to consider going on mute until you want to specifically ask a question. Remember, there is an 8-second delay if you are one of those folks that's watching on Twitch and going to ask a question via that chat room. And if you are in both the Discord chat and Twitch, you may want to turn the volume down on the Twitch so you're not hearing me twice with an 8-second delay. Okay, we're going to go over basically what the 6 degrees of freedom of movement are that is typical of any sort of aerospace flying type vehicle, and then I'm going to go into demo and do a quick demonstration of all those, and I'm going to talk in there on the fly while I'm in Arena Commander on the different integrated flight control system modes, specifically G-Safe, ComStab, and then coupled and decoupled flight. Hopefully I'd like to keep this as quick as possible, something less than hopefully maybe 20 minutes tops, and then so we can get to flying. Anyway, so here we go, and away we go. So there are 6 degrees of freedom on any given physical body when it is not restrained in some way by, say, the ground. They are specifically the, now I'm going to be using aeronautical engineering standards for what the three coordinate axes are, X, Y, and Z. X is forward and back of the aircraft, Y is left and right through the wings of the aircraft or spacecraft, and Z is up and down through your head and your feet when you're sitting in it. So the 3 translational axes, X-axis, Y-axis, and Z-axis, is where the 3 translational axes are called surge, sway, and heave. Surge is when you go forward or backwards in the aerospace craft. Sway is when the aerospace craft moves left or right, and heave is when the aerospace aircraft moves up or down. They also can rotate around those axes, and those are what people are more traditionally familiar with as far in the flying community as far as roll, pitch, and yaw. Rotation around the x-axis is called roll. Rotation around the y-axis is called pitch, and rotation around the z-axis is called yaw. And I have some demonstrations of this that'll make a little bit easier sense for the lay people out there. Now, before I show you this GIF that will help the average person walking down the street sort of understand the 6 degrees of freedom, the labeling on this GIF that I found on the internet is 100% wrong. All 3 axes are labeled incorrectly as far as which one is X, Y, and Z. However, the roll, pitch, and yaw is labeled correctly. So I will kick this up so that you can see it. And it's a GIF, as you can see. So the x-axis is actually the one that goes forward back. So if you translate in X, your head is moving forward and backwards, like you see the guy in the lower right corner. If you translate in the y-axis, left and right, with your head, you see there, that's the guy in the bottom middle with the red. And if you simply stretch your neck and go up or down with your head, that is the z-axis, and you are translating in those axes. Working from right to left, the front back is called surge. You would surge forward or back. If you move your head left or right, you are swaying left to right, and if you move your head up or down, that is a heave up or a heave down. Um, the rolling around or the rotating around those axes, if you look at the upper right corner, which is actually the x-axis, if you twist your head around that axis, that is roll. If you lift your chin up or down in a yes motion, that is moving your head around the y-axis, which is called pitch. And then if you simply twist your head left and right like you're making a no gesture, then that is rotating your head around the z-axis, which is called yaw. Thought that was a pretty slick little gif with the little mannequin guy moving his nugget. Okay, so that's the very quick part of the 6 degrees of freedom, and now we're going to see how we apply that simple concept. But first thing, before I kick into the game, I want you to pay special attention to the flight path marker in the heads-up display, which is also known as the velocity vector. If you're unfamiliar, it is sort of a rounded square that if you are flying straight along the x-axis, you are flying in a straight line, straight ahead, right out the nose of the vehicle, it will be superimposed around and over top of your gun cross. At the bottom of it is a small little caret that will point up if in general that velocity vector is forward out of the aircraft or spacecraft, and it will be downwards if it's generally backwards out of the spacecraft. In the right hand picture here, I used some graphics and displaced it off to one side to show you what would happen, if the velocity vector was off of your gun cross, so you can see it. That's what I want you to pay attention to while I'm flying around here, because it's going to be moving all over the screen while we do it. Okay, so let me go right here. Okay, so I'm in Arena Commander. I'm going to go into single player. And for the stream and Twitch, this just started happening. I don't know why my output is no longer absolutely full screen. It's like 2/3 screen or 3/4 screen, something like that. But it happened just before we started streaming, so I didn't have time to go hunting what the technical problem is for when I'm streaming the game. So anywho, I'm just going to ignore it for now, and we will press on as it is. So I'm going to call up a Mustang Alpha, which is what we're going to try to fly with tonight, either Mustangs or Auroras, whatever your starter ship package is, for the folks that are going to join us. So while this loads in, boom. Alright, we are going to go somewhere else, not there, because that's loud. Okay, so I'm going to move us away from the big laser beam. There we go. And I'm going to fly us over here so that we have some something to use as a frame of reference. Real quick. Alright, so you can already see that flight path marker moving around. Okay, so one more little setup item before we begin. I'm going to actually adjust the exterior camera as well, so that I can use that as well as some point right there. Okay. Alright, so the 3 axes, of course, is X, Y, and Z. X is right where you're looking. It's right out our eye line through that gun cross, right out in front, and also back behind us as well. Y goes right and left out our shoulders, and Z goes up and down through our head. So if we translate in any of those axes, so if I translate forward, if I surge forward, things get closer. If I surge backward, then things move back. Alright, I can also sway right and left with a translation to the right. And then I can translate back to the left. And as if you can see out on the edges of the screen, you can see that flight path marker moving back and forth as I move back and forth, or as I command the stick to go back and forth. The third is obviously in Z, where we heave up, or we can heave down. Of course, a little red out there. We'll talk to G-Safe here in a sec. Okay, that's the three translational movements along the axis, degrees of freedom in other words. There's three more degrees of freedom whether we rotate around those axes. So the first one, if we rotate around the x-axis, that's called roll. So I can roll left, or I can roll right, and then if you rotate around the pitch axis, or the y-axis, that's called pitch. So that basically is, we have zero velocity on the airplane at the moment, or on the spacecraft. So, and of course you can go this way as well. Now notice that when we're doing that, we're not getting any sort of G effects because the spacecraft is not actually moving, it's just rotating. And the last one, of course, is if we rotate around the z-axis, that is, of course, yaw, and you're just sitting around, spinning around, like going like a merry-go-round. And of course we can go the other way. Now notice when I'm doing these rotations, there's no velocity vector because I'm not actually moving. I don't actually have velocity. I'm just simply changing attitude, which is basically means where the nose is pointing. Okay, so if we go exterior, so you can see the same thing. Of course, I can surge forward, or I can surge back. All right, I can sway right. I can sway left, and then of course I can heave up, and I can heave down. Now surge, sway, and heave is really for aeronautical engineers, and I do work at Boeing. So for the folks that are, shall we say, more layman, you would just call that strafing right and left, strafing up and down, strafing forward and back. Of course, we can pitch, pitching around vertically, and then I can pitch up, I can pitch down, which is a rotation around the Y. I can roll, which is rotation around the X. And of course, I can yaw, which is rotation around the Z. The whole time this ship hasn't moved. That's just the 6 degrees of freedom. Okay, so now if you blend it all together into 6 degree of freedom spaceflight, of course, you can get the spacecraft to do some really cool things all at once. And all this, none of this that I'm doing is any throttle in it at all. This is all just, as you'd call, strafing and rotating. So this is a little bit of what people might call circle strafe. If you're going around another target, fighting somebody, you can also do it, vertically, and it works the whole way. Of course, this is an awfully big rock. So that's the 6 degrees of freedom and how to maneuver in 6 degrees of freedom conceptually. Now let's talk about some of these IFCS modes. So I'm coming back inside on the view here. The first one we'll talk about is, I'm actually going to go in sort of reverse of how they're listed on the right side over there. I'm going to talk about ComStab first. ComStab means command stability, and that is basically akin to traction control or anti-slide in automobiles. As you get moving in a direction, so I'm just going to go full throttle and drive this way. As you can see, the flight path marker, I'm using some translation there to move it around just so you can see it, is basically straight out the front. Now, if I decide to turn, you'll notice that that flight path marker is turning with me. That is the ComStab using the thrust of the thrusters to turn that velocity vector at somewhere near the same amount that I'm commanding in the turn. If you notice this speed, though, as I command it harder, as I command more turn, you'll see my speed actually drops off. And that's the command stability slowing the forward velocity down so that the thrusters have enough thrust to be able to turn and keep that velocity vector right near your flight path marker. In other words, it tries to make it fly like an airplane. so that the velocity vector basically changes with the nose. Now, even with ComStab on, if you command enough enough turn rate, you can actually get the nose to depart from the flight path marker faster than it can, as you can see there. And then when you roll out, you will see the flight path marker come snapping back in to catch up to it. So you'll see it will lag, and you will actually be doing some small amount of a skid. Even with ComStab, you can override, you can command more than the ComStab can compensate for, the way it's implemented right now. If you turn ComStab off, which I believe I can, I have a button switch to it, now you that command stability won't happen. Now as I command a turn, it will basically do the same thing, but you'll notice that it's nowhere near as fast getting that flight path marker back to aligned with your nose. So what this means is that as you make turns, they're going to be a little more sloppy. You're going to slide around corners. So let's see if I can get in here like this, and now kind of watch the relative motion of these asteroids as I kind of turn, and I do a hard turn. Now you see I'm actually sliding sideways for a little bit before the actual thrusters in the engine gets enough thrust out there to be able to overcome it. That's basically what ComStab is. Think of it like traction control for your car. When you have it on, it will actually, the computer, the flight control computer, will reduce your forward velocity so that your maneuvering thrusters can turn the spacecraft basically at the same rate in which you're commanding it. If you turn it off, then you're going to be going around pretty much every corner like it's sliding. So watch this. I'll go over these landing pads here, and then just simply make a turn, and watch how much we slide around that corner. Alright, so let me turn ComStab back on. Alright, the next concept I'm going to talk about is the G-Safe. And G-Safe is basically, in the theory, the lore of it, the computer knows how much, how many G's you should be able to take without blacking out. So when you're racing along in a straight line, if you do a hard high G maneuver in the vertical, so up, you will get gray out. Okay, well I didn't gray out because I have G-Safe on. So if I get some speed up, now I can gray out, and I can take it all the way to blacking out if I turn the G-Safe off. See, my guy's passed out in the seat until he wakes up, and then he can gain control of the spacecraft again. Okay, if I attempt to G-lock myself like that without turning it off, I can pull as hard as I can, and it's adjusting speed and pitch rates to keep me from blacking out. Again, if I do it with G-Safe off, and I just pull until I black out, alright, got to build up some speed in one direction first. There you go. You can pull too hard, you start seeing it gray out. And that works, by the way, and it's the same thing in the other direction. If you pitch down, you can get red out, like you see there. G-Safe should limit the performance of the spacecraft to help avoid doing that. Alright, the last one is couple and decoupling. Couple is the flight computer, when I turn, goes, well, he obviously wants the flight vector to move along with the nose. In other words, you're commanding where you want the flight vector by pointing with the gun cross that you have there. If that's not the case, then you can click off coupled mode, as you see there, and if you click coupled mode off, now I can rotate the nose away, and the spacecraft just simply goes, oh, he just wants to spin like on a top, but that velocity vector, as you see to the right, is still floating in that direction. So I'm just sort of strafing on away, and if I click it and turn it back on, now it'll pull that velocity vector back over to the nose. I go this way, click it off, rotate around again, watch this thing go by. The velocity vector is way off to my right. Click it on, put in no control input, but now you've just told the computer, no, I want the velocity vector back towards my nose. So you can even decouple, and now you can see the velocity vectors moving around, but I'm using strafe on the strafe stick. And I can actually now move that velocity vector around without moving the nose. So your translation and your rotation don't necessarily have to be connected. And of course, that all exists in 3 dimensions. Now let's take a look at that from the outside real quick, and then we'll call it good enough and go fly. Alright, so here we are, we're tootling along. I'm going to kick off. I am now decoupled. You can see I'm literally flying sideways. And then if I kick coupling on, now you'll see the engines kick in and now move me the direction I want. I'm going to turn couple off again. I'm going to turn sideways. Here I am flying sideways again. And if I go, okay, that's good enough, I can kick couple back on. And haven't put anything, and it will bring that flight vector back to the nose. All right. So that's it in a nutshell. Where you can actually use 6 degrees of freedom. You can know how to use your couple, your decouple, whether you want comm stab on or not, and of course now you know what G-safe does for you. So you can fly around a little bit and have some fun and actually know what it is you're doing. I just lost all my controls. That was interesting. I got them back now. That was a weird long pause without my controls doing anything. Okay, that's it for Foghorn. We will call that good enough. Alrighty, that wraps us up for this installment of Academics with Foghorn. I hope you found it interesting and helpful. If you have any questions that I didn't answer, and nobody stopped me, so I'm assuming there weren't any questions. Any questions I didn't answer, please feel free to contact me via email, Discord, or Spectrum, or of course the comment section below. I will answer the best of my ability and as quickly as I can. If you are part of the Aurora Republic membership and have not hit the subscribe button for the YouTube channel or follow on Twitch, please hit it immediately and enable notifications so you can remain up to date whenever we put out any new content. If you're a visitor to this channel, please feel free to hit the subscribe button, and your feedback really does help us when we're trying to improve on our content. You can always find us on aurorarepublic.space on the RSI website and Spectrum as the Aurora Republic, and we'd love to hear from you. We'll see you next time. This is Foghorn signing off, wishing you a pleasant remainder of your morning, evening, and or night.